Hi, Brittany. Since I don't know what course you're taking or what level you're at, I'm just going to answer this question with the most simple answer. And I have read the comments and know that your numbers were repeating, so we'll use the correct numbers. So this problem is interested in a 90% confidence interval for the proportion of yellow peas in a specific variety of peas. And so we're going to be using the formula for a confidence interval for a proportion. Our basic variable is a categorical variable. The number of peas, we've got green peas and yellow peas, two categories, the color of peas, green peas, and yellow peas. So our formula is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. P hat is the proportion of yellow peas because we want to construct the 90% confidence interval for the proportion of yellow peas. Percentage and proportion, just the percentage is multiplied by 100, the proportion is the decimal. Z star that basically is the z-score for the confidence level. The confidence level in this case is 90%. So Z star is 1.645. You can find Z star in a variety of ways. You may want to ask another question if you want to know specifically how to do that. The square root, the 1 minus p hat is the proportion of green peas. It's the proportion of failures, the proportion of peas that are not yellow. And n is the total number of peas. That square root of p hat times 1 minus p hat over n is called the standard error, and z star times the standard error is the margin of error. So let's figure out what these numbers are. P hat is equal to the number of yellow peas, which is 159, divided by the total number of peas, which is 442 green peas plus 159 yellow peas, which is 601 peas total. And that is going to give us 0.265 if I round to the 3 decimal places. So 1 minus p hat is 1 minus 0.265, which is going to be 0.735. N is 601, and Z star, as I said, is 1.645. So if we put those numbers into the formula, we're going to get 0.265 plus or minus 1.645 multiplied by the square root of 0.265 times 0.735 over 601. When we subtract the margin of error from our p hat, we're going to get our lower limit of our confidence interval, and that is 0.23496. When we add the margin of error, we're going to get our upper limit, and that's going to be 0.29415. So we are 90% confident that the true proportion of yellow peas for this particular variety of peas is between about 23.5% and 29.4%. Part B says it was expected that 25% of the offspring peas would be yellow. Given that the percentage of offspring yellow peas in our sample is not 25% or 0.25, it was 26.5%. Do the results contradict these expectations? No, these results do not contradict these expectations because 0.25 or 25% is in our interval. So we're 90% confident that 25% is a plausible value for the true proportion of yellow peas from an experiment conducted like this one. I hope that answered your question. If you have any more questions, just put them in the comments. Bye.